Welcome to this explainer. So let's just dive right into it. Have you ever experienced what developers call framework fatigue? You know the feeling. You start a brand new backend project and bam, you're immediately buried under mountains of boilerplate code, rigid ecosystems, and these heavy black box abstractions. It's like you're fighting the tool itself instead of just building your app. Well, today, we're exploring a pretty fascinating minimalist solution to that exact problem. It's called the Parina Framework, and it's basically designed to strip away all that excess and hand control right back to you.
Here's our roadmap for today. We're going to look at Parina as a tool, not a cage, then bootstrapping the front controller, strict middleware and handlers, scaffolding with a routes.csv, and finally, deep security and burning URLs.
All right, section 1, a tool, not a cage.
To really get how this whole system operates, we've got to understand the mindset of its creators. And surprisingly, the inspiration here didn't come from some Silicon Valley tech hub. It actually comes from the silence and vast minimalism of the South American Altiplano. Just look at this core manifesto quote. The core is a tool, not a cage. Everything that isn't there is intentional. I love that. In a modern web dev landscape where enterprise frameworks try to give you literally everything out of the box, which, let's be honest, often traps you in their specific way of doing things, Parina goes in the exact opposite direction. The primary design constraint here is that the code must be simple enough to literally fit in your head. It pushes the responsibility right back into your hands, completely stripping away those black magic abstraction layers so web development can become, a pure creative act again.
This contrast really highlights the two different approaches perfectly. On one side, we have your typical enterprise bloat, rigid, slow, overly complex, and on the other, Parina minimalism. But hey, don't let the word minimalism fool you into thinking it's not robust. Underneath its quiet exterior, Parina is actually heavily engineered. Check out Parina's near-perfect 9.92 Scrutinizer code quality score. Fully green, passing builds, that's huge. It basically proves that you don't need a massive footprint to have high-quality, production-ready code. Moving on to section 2, bootstrapping the front controller.
So let's see how this philosophy actually builds into the technical architecture. How does a framework this lightweight start up when a user visits a page? Well, the defining feature here is how lightning fast and linear this entire lifecycle is. Every single application lifecycle kicks off through 3 exact steps. Step 1, an HTTP request hits the system and triggers public/index.php. Step 2, a highly efficient router is instantiated to parse the incoming paths. And step 3, the kernel takes over to execute the application run loop. That's it. It doesn't load 100 unnecessary modules. It just loads exactly what it needs to figure out where the request should go.
But actually, before that request even arrives, Parina sets up this incredibly strict defensive posture right through its deployment structure. The framework physically separates your public assets from the core application logic. So your public files, like your index file and critical HT access, go to your web server root, like var/www/html. Meanwhile, the entire framework core and your modules reside completely outside the public web root in a folder like var/www/parina. What does this mean? It means attackers absolutely cannot even attempt to peek at your internal files because they literally do not exist in the public-facing directory. Combine that with a standard composer optimization command for production, which flattens the autoloader, and you're left with 0 execution overhead and maximum security.
Okay, section 3, strict middleware and handlers. Let's unpack what happens the split second after the kernel takes over that request. We'll start with a clear definition here. Parina uses a middleware pipeline. This is a strict, linear sequence of checkpoints. Think of it kind of like a security gauntlet. An HTTP request absolutely must pass through these checkpoints before it is ever allowed to touch your core application logic. Now, these layers are highly dynamic, and each middleware has a very specific job. It can inspect the request, it can modify session parameters, or it can completely short-circuit the flow altogether. For instance, say you have an off middleware, and an incoming user's session is invalid. The middleware catches it instantly. It doesn't even bother waking up the rest of your app. It simply halts the pipeline right then and there and returns an error response 401. This instantly saves vital server resources. But on the flip side, if the session is valid, it cleanly passes execution to the next layer. And that pipeline always ends at one specific destination. The final stop is the handler. The request lands here, strictly adhering to an interface that guarantees a predictable outcome. The handler processes the valid data, renders a clean view, often using a layout pattern, and returns a standard HTML response with proper HTTP status codes. It is incredibly clean, it's highly testable, and deeply, deeply predictable.
Next up, Section 4, Scaffolding with routes.csv. Okay, let's talk about the developer experience for a second. Because if you're building an application, you know for a fact that setting up routes, creating handler files, and writing tests can become just a tedious boilerplate nightmare. Well, Parina solves this by not forcing you to write massive, complex configuration arrays by hand. Instead, it lets you architect your entire application structure inside a plain text CSV file, literally just like a spreadsheet. You simply map out your HTTP method, the URL path, the handler class, and any middlewares you want to apply. So as an example, a GET request for /about maps directly to about handler, while a POST request to /login maps to a login check handler protected by an auth middleware. You just lay out your whole app line by line. And here is where the massive time savings really happen. Once your CSV is ready, you run exactly one terminal command, php bin/scaffold.php routes.csv. That is it. The framework reads the CSV, parses the data, and automatically generates your production routing configuration files. It even scaffolds out the necessary handler classes and PHPUnit test files directly into your source directories. It completely automates away all that boring architectural setup. And our final section today, Section 5, Deep Security and Burning URLs. So, we've talked a lot about minimalism, but let's look at how Parina packs a really heavy punch when it comes to deep security. Parina actually has this built-in cryptographic system for creating self-destructing, Mission Impossible-style URL hashes. Let's walk through this timeline together. Let's say you need to send an admin a secure temporary link. At T-1, the framework takes the query parameters and injects a time to live, or TTL, timestamp, usually adding about 30 minutes to the current time. At T-2, it encrypts the whole package using strong AES 256 CBC encryption. Fast forward to T-3, the user clicks the link. And finally, at T-4, the framework decrypts it and checks the timestamp. If that time is expired, the validation intentionally fails, throwing an exception. The URL effectively burns and can literally never be used again. So, you might be wondering, how mathematically secure is this payload under the hood? Well, for the crypto nerds out there, Parina doesn't cut any corners. It uses OpenSSL_raw data to get highly compact raw binary encryption. Then it sequentially packs a 16-byte initialization vector, a 32-byte HMAC signature, which acts basically like a tamper-evident seal for data integrity, and the encrypted data itself, wrapping it all cleanly in base 64. When decrypting, it strictly uses PHP's #_equals function to verify the signature before it even attempts decryption. This creates a really solid mathematical shield against malicious timing attacks. It's absolute data integrity and tamper-proofing right out of the box. Wow, we have covered a lot of ground today, from the pristine silence of the Altiplano Manifesto all the way to the heavy cryptography of self-destructing URLs. Parina truly proves that a framework can be a tool, not a cage, giving you strict pipelines, automatic scaffolding, and unbreakable security, all without trapping you in bloated abstractions. So I'm going to leave you with this question to chew on. With code this clean and an architecture this empowering, what bloated legacy project are you going to refactor with Parina first? Thanks so much for joining me on this explainer, and happy coding.